The broadcast is now starting. All attendees are in listen-only mode.
Hi, everybody. Thank you for joining us on this Friday afternoon. I have a couple of people with me today for our webinar on solutions for transportation. Starting the webinar is going to be Tom Ferris from Alliance Communications, going to do a brief introduction. And after that, it's going to be Eric Dalton from Redline Communications doing the main presentation. We are recording this presentation today, so after the webinar is done, I'll create a video file that I'll be uploading to YouTube. So if you want to watch this over and over again, you can, and you can send the link to colleagues. So I'll be sending out an email to follow up after the webinar with a link to that and a link to the actual presentation. The other homework thing I want to mention was we did receive all the questions that everyone asked during the webinar or during the registration, and we're going to address them during the presentation if we can. If not, we'll take them offline. If you do have questions throughout the presentation, you can ask them through, I'm not sure what you see, if it's a questions or a chat option on the GoToWebinar console. You can just type them in there, and we will take them generally at the end of the presentation. So with that being said, I'm going to hand things over to Tom, and he can get started.
Thank you, Lisa. Thanks very much. Welcome, everybody. Thank you for coming on this beautiful Friday afternoon here in northern New Jersey. I'm hoping everybody got through all the bad weather we've had here on the East Coast. I know we have a lot of transportation people in the room, so I'm sure you've been dealing with a lot of challenges this week with flooding and whatnot, and I appreciate you all taking the time out of your busy schedules to come and join us today. So, as Lisa said, we are talking about broadband wireless network solutions for transportation. Seems to be a lot of activity in the transportation space these days. Maybe that's because there's a lot of federal funding, or there's a lot of new technologies that are coming out that address a lot of the issues that the transportation community is having today. But with that comes a lot of need for higher capacity out to the edges of the network. And what we're going to show you today is solutions from Redline Communications on how we can extend your IP networks as far out of the network as possible to a variety of different land-based, ship-based, mobile-type devices, right? So as I mentioned before, we're going to focus on transportation applications today. We've been working on a lot of applications over the last 2 or 3 years. And some of the things we've been seeing, I just wanted to point out here, and these are some of the things that we're going to be addressing today. So in the transportation space, specifically for intelligent traffic systems, this is probably no surprise to anybody, but video surveillance cameras are popping up all over the place, up and down our roadways and throughout our municipalities. There's also a lot of traffic control devices being deployed to register and monitor and control the flow of traffic onto and off of our highways. We've gotten involved in a lot of bridge monitoring projects lately and a lot of lane change type systems out there that are being used that require low capacity communication requirements, but communication requirements nonetheless. And then the other things we're seeing are integrated corridor management and information systems, whereby all of this data that is being generated by all these devices on highways needs to go somewhere. It needs to get correlated. It needs to get massaged and mined and everything else. So with the new technologies available through companies like Redline, we're able to grab all this information at all these remote locations, bring them back to central locations. And in the public safety space, one of the big applications today is workforce mobility. Moving the desktop and all the applications you have on your desktop as far out to the edge of the network as possible. And to do that, you need capacity, you need mobility, you need portability, you even need cellular-like type services. And Eric will show you a little bit about what we're doing in the public safety market today as well. Mass transit, anything that moves out there that's for the public transportation space, whether it be ferries, light rail systems, underground or above ground subway systems, somehow, some way we're getting Wi-Fi on these things. And this is being done through a variety of different RF technologies, and we're going to go over some of those today as well. And then in the shipping and airport space, again, pushing a lot of these real-time applications out to the airstrips or out to the out to the edge of the shipping docks to provide better control, better information, and better real-time automation. Just to give you a little bit of background about Alliance Communications, Alliance is a value-added distributor with a prime focus on wireless RF technologies. We provide a variety of products and a variety of solutions. So in the microwave backhaul space, we provide a variety of different radios that operate anywhere from 600 megahertz all the way up to 80 gigahertz, licensed and unlicensed solutions, point-to-point and point-to-multipoint. In the infrastructure space, we do a lot of work with the cellular carriers here in the U.S., assisting them with supply chain as well as all the products that go into attaching radio and radio systems to basically towers, rooftops, or anything that might move out there as well. We also have a variety of IDAS and ODAS products. These are systems that bring cellular connectivity inside buildings or in outdoor areas where you have large concentration of users, such as entertainment stadiums and whatnot. And we also provide a variety of fiber optic cables as well as fiber finishing services. So I don't know if anybody's familiar with this, but in the 4G world these days, fiber optic is basically replacing coax for a lot of 4G radio systems. And we're getting into a lot of different hybrid type fiber cables. And some of these cables you might see popping up in some of your systems as well. And then to top it all off, we provide supply chain solutions. For companies like AT&T, T-Mobile, and Verizon, we provide them basically local logistics centers to provide both inbound and outbound management of all the products and equipment that are required on large-scale deployments. To get into, and on the technical services side of our business, we provide complete technical support, anything that can be done pre-sales for a project, from network design to licensing, microwave radio systems. We do path profiling, pre-configuration of radios before they go out to our partners and into the field, and all types of racking and stacking and kitting type services. We also provide a variety of services to our manufacturers as well, including Tier 1 technical support and RMA support. Just to give you a little bit of idea about the wireless broadband solutions that we tend to focus on here at Alliance. These are some of the top names in the business. These are generally the number 1 or number 2 players in their respective markets, companies that provide a high level of quality product as well as service here in North America. And this is anybody from, like I said earlier, any radio systems from 600 megahertz up to 80 gigahertz, licensed, unlicensed systems, mesh, WiMAX. We also have a complete selection of towers and a variety of different AC, DC, and UPS products. That's all from the Alliance side. Again, I want to thank everybody for coming on board. I'm going to turn it over to Eric Dalton in a minute, and we're going to get into the meat of the presentation. We asked prior to this session, we asked a bunch of questions, and I'd like to thank there's about 10 or 15 attendees that provided questions that Eric has on a list. He's going to try to address all of these today. If we don't get to all of them, we'll try to take these up individually with you all offline. And with that, I'd like to turn it over to Eric Dalton of Redline Communications.
All right, thank you, Tom. Can everyone hear me? Are we on, Lisa?
Yeah, maybe you're a little bit fuzzy.
Okay. Is this any better?
That's way better, yeah.
Okay. So hopefully everyone can see the presentation that's currently there. If you can, please let me know. Perfect. All right, so I'd like to thank everyone for showing up today. As Tom mentioned from Alliance, my name is Eric Dalton. I work with Redline Communications. Been here about 10 years now. And we're going to talk about, I guess, some of Redline's technology, specifically within the transportation system area. All right, there you go. So brief background on Redline. Redline is a company that's been around since about, I guess, 1999-ish, somewhere in that realm. We're about 15 years, I guess, in the making, headquartered in good old Toronto, Canada. We have about 150,000 systems globally now in 100 countries, and we're a publicly traded company. So Redline's been a company that's been doing RF now for quite some time. Our technology is built all in-house by our own engineers, and you know, we've had some success, if you will, over the years. From a transportation specifically, this is kind of a layout, if you will, from a global perspective of where we've done some transportation projects. There's some flash names of different case studies and things that we've done with respect to projects. Clearly, that's not all of them, some that obviously we're not allowed to talk about. But as you can see from a reach perspective, we've been doing transportation projects for quite some time, and a lot of our technology, based on the requirements within the transportation industry, have been focused on making those efforts better. From an intelligent transportation system perspective, the entire network, if you will, is about increasing traffic flow and overall infrastructure efficiencies. The funding typically for transportation is very straightforward. It's a set item. Most of the municipalities and states, as well as some of the provinces and things in Canada, it's a set infrastructure thing, and it's all about making things quicker and less expensive, because obviously building roadways, there's only a limited amount of things that you can do with doing that. So using technology to become more efficient in this space is where we see obviously people heading, and because of that, we're building systems in order to do that. But from a wireless perspective and this technology in general, the systems always have to work. So the reliability side, when you talk about transportation systems, becomes extremely key, because you can't be putting systems out there that work half the time, or it's up or down. It's a system that has to work reliably all the time, and that's where kind of Redline has had a great deal of success, if you will, over the years. From a division of the network perspective, typically we have the intelligent vehicle management systems, the ATPS systems, as well as the video management systems sitting in the core. And then, of course, everyone sees the edge devices, the different traffic cameras, intelligent sensors, signage, things along those lines, all at the edge. And, of course, Redline's part of this, and what we do is try to bridge those two things together so that you can sit in your core and be able to monitor things from your core all the way out to your edge device seamlessly, so that all of these edge applications, if you will, can work and flow right from your core network. So specifically, some of the applications and things that we're seeing that we're providing services to today, and I've got some case studies later that we'll talk about, are of course your road sensors. Video surveillance is a huge, huge, huge portion of what we're doing, or what we're seeing, if you will, on the transportation side. And video as an application is very interesting, and a lot of times hard to do over wireless. And we'll talk about why Redline has succeeded specifically in those applications a little later. On and off signage, flow control when it comes to on-ramps and things, and general Wi-Fi and hotspots, so that we can see the the central and monitoring people back in these NOCs and cores, being able to control all aspects of these networks, no matter where they exist along the roadways and some of these hard-to-reach places. From a technology perspective, Redline has both point-to-point as well as point-to-multipoint technology. This slide briefly talks about some of our point-to-point technology that we're currently using within the industry of transportation. We have an all-integrated solution, so it's literally 8-inch by 8-inch, and I got a slide later that kind of describes it in more detail. And we also have I guess a non-integrated portion where you can use your own antenna to be able to connect to some of these harder to reach or longer link capacities, or where the need for some different strange antennas may exist, so that you can actually buy whatever antenna you need to kind of couple with your system. More popular is obviously the multi-point line, which is Redline's virtual fiber line, which consists of a sector controller, which we nickname Ellipse. We also have our endpoints, or our subscriber stations, that, if you will, go off of our multi-point controller. One of them, again, being that enterprise unit that we discussed earlier, the edge that we just talked about, as well as a very, very interesting product that I'll spend some time talking about in a few minutes as well, called our RAS platform, our Rapid Antenna Steering Platform. But one of the key things that Redline as a technology vendor has had a great deal of success with, especially when you talk about success in different areas of the world, not only within Canada and the US, is our frequency family of products. So from a frequency perspective, we have products in the UHF band, lower 2 gig, upper 2 gig, 3 gig, and 5 gig. And the cool thing about this is that once you buy a product, it's the exact same product, exact same look and feel, exact same training, regardless of the spectrum. So if you're deploying in one area and you need access to a specific frequency, you buy a box. And it's a different frequency box for a different frequency, but the training, the look and feel, the installation, the GUI, everything is identical regardless of the spectrum. So it becomes a key differentiator for Redline, especially when you're doing different services in different parts of the world, especially where spectrum is different between different places. You have one technology that can work in various frequencies up and down your own license line if necessary. From a sector controller perspective specifically, our Ellipse product gives you about 120 megabits per second in a 20 megahertz wide channel, less than 10 milliseconds of latency, and a tremendous amount of processing power. And again, I'll talk about why processing power in particular is important a little later. But it's a workhorse of a solution that has done extremely well. From a subscriber side perspective, again, the enterprise unit that we talked about earlier that works in both point-to-point as well as point-to-multipoint gives you about 100 megabits per second, again, in a 20 megahertz wide channel, less than 10 milliseconds of latency, which is extremely important when you think about real-time application. But the cool thing about this product is it has an integrated antenna built into the box. So for the transportation industry in particular, footprint sometimes is extremely important. So as can be seen from the slides on this, from the pictures on this slide, it's 8 inches by 8 inches by 4 in size, all integrated design. The only thing you have to do with this product is literally bring a Cat5 cable up, which provides both the power as well as data access to the radio itself. So it's an all-inclusive product, great small profile, if you will, if you need it in those areas. And, the antenna gain varies depending on what the frequency is, but it's a very small footprint product. It's also IP67 rated for ingress protection when you think about water and sand and some of the environmentals that you do. This is, strongly certified, if you will, for operation in there. And software-wise, like most things within radios or within Redline, you have different speed options that you can actually purchase depending on what you're trying to accomplish. So on day one, for example, if you wanted to have the radio work at a 12 megabits per second radio, you can buy a key accordingly that unlocks that modulation to get there. If at some point in the future your operation changes and you would like the radio to go to a higher level, well then you can buy a key that would unlock functionality to go to a higher level, so it allows you to kind of pay as you grow from a frequency strategy perspective as well as throughput. So it's been a product that's done extremely well when you need a small profile product for some of these transportation deployments. Another product, which is supplementary obviously to the one we just discussed, is something that we call Edge. So again, this product works in both point-to-point as well as point-to-multipoint, same specs from a throughput and capacity perspective. And of course, the big draw with this product is the fact that you have the two type of end connectors exposed on the radio so that you can use bigger, different antennas to plug into this product versus the other one that had the integrated product. So if you needed, a kind of a bigger dish in order to go further, if you will, from a distance perspective, you're able to couple any antenna that you want with this radio, because this radio is antenna agnostic, in order to go from point A to point B, through distance. And again, you still have the same temperature ratings, the same IP67 certification for ingress protection, same speed options, if you will, from a throughput perspective. So it kind of gives you the other end of the spectrum when, again, you need kind of more of an antenna to potentially connect points, that may be further away or a different application. Our RAS Elite platform has been one that's been very interesting, and especially when you talk about first responders and ports and things that are kind of nomadic in nature, the RAS platform for Redline has done extremely well. So RAS stands for Rapid Antenna Steering System, and it's basically almost like a beamforming antenna. So we have a radio on the bottom, and then you have this kind of 9-inch circular, almost looks like an Omni antenna kind of sticking up out of the top. And what it does is it allows you to automatically connect to base stations almost like you would from an Omni perspective without ever having to point it, except what it does is it doesn't spew RF energy like an Omni would. So to kind of give you an example of that, this slide kind of will step you through different lobes, if you will, within the 360 degrees as pictured almost like that flower diagram. And what happens is as soon as you apply power to the RAS, it goes into the search mode where the beamforming array goes around and around and around looking for an ellipse base station to actually connect with. So when it finds an ellipse sector controller to actually connect with, it shuts off all of the rest of the errors that are in the technology platform and focuses all its energy towards that place. So from an alignment perspective, you get the entire benefit of having an omni-like antenna that you never have to point, and you get the coverage area of a narrow beam point-to-point antenna, because when it focuses its energy, it's no longer spewing energy out in all directions, but focusing it towards one point. So you get the antenna gain of having something that's over double what the normal gain is on an omni, focused in one area, so that from a capacity perspective, you're able to capitalize on that and go further than you typically could. So if you think about nomadic type applications where you're going as a first responder to a location, or you got a ferry service that's moving between specific points, as this thing is traversing through different areas, once it passes the criteria that you're able to set as a user for what the RF characteristics are, it'll go back into search mode, reconnect on a different angle, potentially if your orientation has changed, and then connect back up again and give you that broadband connection. So it's been a product that's done extremely well for Redline in that, again, first responder type approach. Redline as a company as well offer a whole host of services for people that need things like RF planning, mapping, integration, things along those lines. From a project management perspective, there's a certain class of, RF networking where a lot of times it's nice for the manufacturer to actually step in and assist with the RF design. We offer services as Redline in order to kind of come in and work with the different integrators in order to come up with a frequency map of deployment that we can stand behind and guarantee in different deployment areas. So now that we've talked about, I guess, the technology, kind of at a high level, let's talk about why Redline. I get asked this question all the time. So, we see, specifically for the transportation area, the four biggest challenges that we see, different people come back and ask us is range versus capacity. It has to be reliable. Line of sight to remotes is usually always an issue. And then, of course, you always get the spectrum question. Depending on where you live in the world and what's access, what do you use and what do you not. So the next slides are kind of go over some of this in more detail. So range versus capacity, the base station cost. A lot of times the infrastructure cost is actually the biggest cost within a network. If you think about the cost of a radio on a tower or on a building or on whatever, it's pretty minuscule, if you will, when you consider what the cost of the actual tower or structure is in general. So the transportation industry typically is always a fixed access. They're usually not given budget to go build towers, buildings, and those things. So the assets that are available along these roadways or around these ports is very, very key. And what they want to do is be able to maximize the range and get the biggest amount of capacity or biggest pipe they can for those assets, because the expenditure of trying to put more assets in place is tremendously expensive. So Redline as a technology, and that's why we've been chosen for a lot of this activity, typically will go further with a bigger pipe than other applications. So it's key to that infrastructure. Reliability. Redline as a company, we've been doing business with people like the US DOD. We're doing a lot of things in the energy sector. And the reason that we're having that success is the absolute reliability of the product. There's a bunch of technology out there today, I'm not going to name names and go through it, that, it's built, in a plastic enclosure, it's meant to do something, and if it breaks, who cares? You dispose of it, you get another one, and, that's the model. Redline as a technology doesn't host that kind of mentality in the fact that we're building products, they're ruggedized, they're rated for extreme temperatures, and we've got deployments in some of the hottest and coldest places on the planet from a temperature perspective. We have them offshore on oil rigs, we have them in the deserts, we got radios, in the North Slope of Alaska. We're in these places that if a radio breaks, it's probably 2 or 3 days of a guy on a plane and driving and things like that to get there. So reliability comes first above everything else. So that's why when you look at the RMA of our product, which is second to none, and you look at the MTBF of our product, which is 20 years plus, these radios are built to last. They're not meant to be put in and babysitted because, again, the applications that generally are going over our radios are more mission critical and they need to operate at all times. So, there's a benefit, if you will, in making that. Of course, the line of sight question and spectrum always comes up. As you can see from the picture, which of these installations, if you were going to deploy some type of video surveillance product or something like that, would you want to do? And of course, the real answer is the closer you can put radios to the ground and use your existing infrastructure, the better off you're going to be as a technology vendor and as a society, if you will, in being able to put things in video surveillance in places where you actually need it. And, you know, let's face it, we're blending in with the environment. The hills and valleys and buildings and things like that are in place, and you're having to work within these areas. So from a Redline perspective, you know, we have a host of different products in different frequencies specifically that can greatly help the non-line of sight type of applications that we're seeing that most people need, especially when it comes to the ITS infrastructure. Because typically they're in places that are hard to reach, and you don't have a lot of height off the ground with a lot of this stuff. So one of the technologies, obviously, that Redline uses, and a lot of people tout this all the time, is MIMO. And I find a lot of people hear the term MIMO a lot, but they don't really understand, you know, that, for example, there's two different types of MIMO. There's one called MIMO A, and there's one called MIMO B. From a MIMO A perspective, the whole premise of MIMO A and why it works is to improve signal quality. So you're putting in this in places where the RF is really noisy, or you're in a place where non-line of sight is happening, and you're trying to make sure that data goes from point A to point B, and still, you know, when you're sending a 1 gets there. When you're sending a bit 0, the 0 gets there. So it's all about improving that signal quality in different ways within the radio in order for traffic to go. So again, that's the MIMO A stream. MIMO B, which is more popular and usually talked about, is when you double your data. So if I'm in a great RF environment and I'm going to transmit data between point A and point B, MIMO B technology allows me to get a bigger amount of signal by using kind of, you know, using your antennas to send independent streams so that the radio can combine them on the other side. So from a Redline perspective, we actually implement both. And we implement both on the uplink as well as the downlink. And from a sector perspective, because all this guy ties back into a master, on a link-by-link basis, we can choose which one is going to be used by what and independently make that choice. There's technology out there today that has to use MIMO one way, and if you're using it, everyone in the cloud has to be the same. You know, Redline did away with that. We put a tremendous amount of processing power in our units such that when a subscriber that's really, really far away needs to use MIMO A, he uses it. And within the same sector, if I got a guy that's across the road, he can use MIMO B, and both of them are served independently with no effect on the other. So it's a tremendous differentiator, if you will, for Redline. If we look at some of the 4G technologies, like the WiMAX LTEs of the world, they use MIMO A and MIMO B, but they only do it in the downlink. So you've got these tremendously expensive base stations and towers that are second to none. They're first class. They do a tremendous job of what they do. But if you look at the uplink side, they don't do it in the uplink. Typically speaking, you know, of the WiMAX and LTEs of the world, the subscriber side is generally a lower cost device. It's mass produced, and the whole essence, if you will, of those products is to generally keep the subscriber side as low and as cheap as possible in order to, you know, get your network in place. Well, if we look at the ITS infrastructure and transportation in general, it's an industrial network where 99% of your bandwidth is actually upstream. So if you think about your sensors and your video and, you know, all of these things that you're trying to serve, they're all on the other side of that subscriber. So using a technology that doesn't have things like MIMO A and B and things like that on the uplink side will severely limit what you can do, and a lot of the benefits of these systems are lost because you're uplink centric. You know, again, all your video and all these things are coming from the subscriber side into the core. So it's a completely different model, if you will, from the service provider model, which most 4G technologies were built for. So it's kind of a different mode of operation. From a spectrum perspective, you know, if you kind of look at the spectrum across the board, which this sheet does, you know, you've got your non-line of sight technology, you've got your near line of sight technology, and then of course you got your traditional microwave, which is the line of sight technology. You know, unlicensed spectrum, where unfortunately a lot of guys, you know, have to live, if you will, when they're deploying these systems, because a lot of them do not have their own allocated spectrum. You know, Redline works in this realm. You know, we're working in the non-line of sight, near line of sight, unlicensed bands, and we have radios that go, you know, all the way down to 400 megahertz, all the way up to 6. and that's our bread and butter. And as a technology company, I mean, Redline has been making products here for the last 15 years. We see a lot of companies kind of doing something and then doing something different and jumping in and out. From a Redline perspective, we've been doing one thing very well for a long time now, and again, this is our bread and butter. So from a range versus throughput perspective, just to kind of put it in perspective, because a lot of people say, 5.8, great, 3 gig, who cares, UHF, what does that mean? This is kind of a chart, if you will, to kind of lay out the difference, more importantly, in reach that you get depending on what frequency you're allocated to. And the biggest thing these days within the US and also in Canada now is the opening of the UHF spectrum and what that brings to the table, especially for vendors that are able to use it, depending on where the TV broadcast systems are and if they're able to. But that UHF spectrum in particular can go an extremely long way. We finally were able to come out with an OFDM-based radio with all of the benefits and the, bits per hertz and things in that spectrum, and we see a tremendous uptake and benefit, especially when we start thinking about applications on water and, ferry services and things like that. We've had some very impressive, demonstrations and case studies with different navies and ferry services around the world, specifically in UHF, that have even exceeded the engineers' expectations for reach, just based on the fact that it travels so far and so fast in the OFDM frequencies. So it's a pretty impressive thing. Video, I talked about a little bit earlier. Video is a tremendously tough thing for wireless systems to do. And the reason for that is, and we kind of had to go through this based on a video surveillance network that we did in Mexico, which is probably one of the biggest video surveillance networks in the world, is that when video pulses as a technology, it expects, first of all, that you're at wired speeds. So it's expecting 100 megabits full duplex all the time. And if you kind of peel back the layers on how video actually gets sent out over the wire, it gets sent out in different ways. The first thing is something called an iframe. And the iframe is really the big picture. So it's everything you see on the screen, it gets digitized and sent. And then what happens is you get these deltas to the image, and the deltas are called p-frames. So what you get from a technology perspective or from a traffic perspective is a tremendous burst of traffic, which is extremely large, and then you get a whole bunch of small little frames beyond it, which are the deltas in the image from the initial frame. So that's kind of how it works. Now, from a radio perspective, on the wireless side, the problem with iframes, because they're so big and massive and a flood of data, you have to cache them. So from a buffering perspective internally, you have to have the right memory structure and things built into the radio to be able to grab that iframe and then pulse it out in the time of the radio. And then the other thing you got to do, of course, within the radio is all these little small deltas, which are p-frames, you've got to have a really fast processor in order to be able to process these deltas or these, p-frames in order for video to work. So radios significantly usually can't handle either, and that's why, Redline did some things to change that up. So from a buffering perspective, again, the iframe is sent out at 100 meg full duplex, and they have to be buffered. So if you don't allocate that within the radio, you'll absolutely kill video. From an application perspective, if we kind of look at, different sizes of different applications, we got the SCADA data at the low end, then you got your video, which is kind of still small packet, you got voice, which again is small packet, and then of course you get your traditional file transfers and internet, which are kind of at the high end of the packet size. But if you look at industrial applications, like again video and voice and some of the things that people are sending over these networks, they're traditionally small packet sizes. So from a small packet size perspective, if we kind of were to graph that and look at some of your traditional technologies, when we're looking at the uplink capacity for this stuff, most radios, especially on the uplink side, because again, usually they're purpose-built, they're cheaper, they're ASIC-oriented devices, and they don't have a lot of processing power, you're not going to fully realize these data sheets that everyone keeps talking about, and the big one with Wi-Fi is always, oh, look, Wi-Fi does 300 meg. Well, Wi-Fi will only do 300 meg or some value close to that if you're sending large packets. If you're doing small packets, which again is from an industrial perspective, SCADA data, voice, video, which are the killer applications typically that you're building these networks for, the radios die and they can't give you those same values. What Redline chose to do was put enough processing power into its system so that when these applications come in, regardless of packet size, we're going to give you line rate all the time. So the engine, if you will, within the product is 18 or 20 times faster than typical processors in these radios in order to keep up with the small packet size, so that when we say we're going to give you 100 megabits per second, we're not going to asterisk that and say, oh, by the way, that's got to be 1,500 packets. It can be done with 64-byte packets. So processing power means something very, very, it's very, very important, especially when you start talking about video, which is usually what the IT infrastructure will carry at some point. So to kind of, draw that point to conclusion, this is kind of what happens. You have 100 meg capacity or a 300 meg capacity, and you have some value, if you will, coming out of the wireless system, and then you have this processor, if you will, in the middle that has to take the data from the Ethernet side and spin it over to the wireless side as fast as it can. Well, if I'm sending 1,500 byte packets, which is your typical FTP sessions or internet, I need, about that number, which is a little over 8,000 packets per second, in order to achieve 100. And that's typically what these devices are, and that's fine. But if I was to change the packet size to more video and voice oriented, the amount of processing power that I need in the system to be able to take that data and still fill up that wireless pipe goes up significantly. And that's why we see a lot of these, devices that are kind of not built for this, industrial space absolutely fail when you start putting video and voice and some of these killer applications on there, because they really can't keep up from a processing perspective. So you take something that has a data sheet that, goes on about how great it is and how much speed it can give you, but if you're not sending the right type of information, the system dies and it can't give you near what it's stating it could. So from a Redline perspective, and again, it didn't happen because we were good citizens and wanted to. When we dug into this video surveillance network in Mexico 5 years ago, we quickly were brought to the table with the Pelcos, Bosch, Sony, Axis. I mean, these big bad cameras, if you will, from the different vendors, and we had to peel back the covers on how they actually operated and what we needed to do within a radio in order to make these work. So based on that, Redline actually came up with something called Video Link, which allowed us to change the internal structure of how our radios worked in order to have the correct buffer sizes, the correct latency, the correct processing speed in order to handle video in an effective way so that we could work with wireless systems and have them work successfully within the network. So it took a tremendous amount of time, but we've had a tremendous amount of success and did things where others failed wholeheartedly. Redline continues to work based on these changes. So the next thing I wanted to talk about is case studies. So you've heard about the technology, you've heard about why a lot of people will pick Redline for some of these things. The next thing I wanted to kind of talk about is 5 case studies that we've done, and this is just kind of a sample of some of the things that we've done more locally. I figured it would be better to talk about local things versus talking about other countries of the world, where we were selected as the ITS solution for transportation, and some of the reasons why we did do that. First one would be UDOT. If we talk about the Utah Department of Transportation, when they came to us, their biggest challenge was absolutely reach. They have a tremendous area that they need to reach. They have a set amount of assets, if you will, like we discussed before, that they can put radios on, and they needed to cover a tremendously big area and put out a bunch of different high-value sensors as well as video surveillance over a big physical domain using very few radio sites. So from our perspective, and why they ended up choosing us, is that, again, from our technology perspective, we were able to have links at greater distance compared to other people. Our spectrum mask and our different ability of having different spectrums, whether you were using the unlicensed band and 3 gig, or you were going to use the, the 5 gigahertz bands across the band, they had a lot of places, if you will, within our technology, one radio that they could use regardless of spectrum. And of course, the MIMO side on the uplink side. They quickly found after doing testing that, a lot of these radios talked about, this much up and this much down. But when they actually put them to testing, they found very clearly that, the technologies when it came to video specifically, couldn't even come close to what the spec sheets were quoting them at, and they needed a solution that would work across the board regardless of what the packet size was. So that's how we came into getting the UDOT stuff. We did some case studies on it, and they continue to buy our equipment today. The next one that we did is Nevada Dot. So we've got some technology there. They have a different weather pattern, if you will, compared to what we were seeing before, where they had some rugged conditions, heavy salting on the roads, of course, for 8 or 9 months of the year, depending on where you are. And again, they needed a system that was going to work in some pretty rugged conditions based on temperatures and waterproofing and things they were using on the roads in order to keep people safe. And they chose Redline based on those things, and again, the camera draw. So the reliability of the radio from a 20-plus year MTBF, the rating on the outside of our radios that can work in these harsh conditions, with salt and all these things going on, as well as the extreme conditions. These are the reasons why the Nevada Dot people picked Redline and continue to use Redline today. So again, going back more to the reliability and range that we had within our product. The next one was Massachusetts Dot. So if you look at Massachusetts as a state, it has a lot of trees and foliage, and they're looking at covering bridges and getting infrastructure, on the bridge side of things, which are behind canyons or in valleys. They're kind of all up and down the state. So they needed a reliable product that could work within some of the interesting problems of the trees and valleys and things like that around, that could still get signals, even though a lot of this stuff was going to be non-line of sight to the end areas. So they looked at our technology, they looked at a host of others, and we were able to come across, I think, about 28 different bridges and give video surveillance to these, even though they were in very hard to reach places. So from a MIMO perspective, and I talked earlier about the MIMO A side of the radio specifically, the time block coding, if you will, within the radio from a MIMO A perspective was able to allow us to have links that no one else could give you based on that MIMO A functionality within the radio. And again, the real-time application, the real-time processing, small packet type stuff, all of this built into the radio gave it a no-brainer for these guys, and again, that's why they're using our equipment. Next one was the New Jersey Turnpike. It's a tri-state area. Unlicensed spectrum is extremely saturated. When you're looking at the turnpike, where it is, its proximity, of course, to the, some of the big cities around, finding available spectrum is always going to be a chore. And like we started off saying, most of these guys are not given any type of spectrum that they can use themselves. They're having to figure it out and live within the noise floors of what's available. So they need something that can work in some pretty harsh RF conditions, but still be able to give you legitimate capacity, for all of these video surveillance, smart signage, and ITS sensors. So from a Redline perspective, we have products, again, that start down on the megahertz level, go all the way up to the 5 gig stuff, so that depending on where they are, they had a lot of choice from a frequency deployment perspective within these unlicensed bands to be able to deploy a product. And we could train their workforce on one product. Here's what it looks like, irrelevant of spectrum of how you can deploy it. And because our radio platform was identical across the board, it didn't matter if they were deploying a 3 gig or they were deploying a 5 gig or anywhere in between. The same training, the same way of deploying was consistent across the board. So it was easier from a workforce perspective. Obviously also within the radio, the software adjustability within the radio that you can actually pick different channel sizes. And if you're in an area like New York where there's not a lot of available spectrum, going to smaller channels because of the bits per hertz thing that we have within our radio in order to give you high capacity becomes important, because we can probably do as much in a 10 megahertz wide channel that some people need maybe a 40 megahertz wide channel to do. So the bit efficiency for spectrum also was an extremely big driver for these guys, so that we could fit in and out between some of the frequency that was available, but still offer the amount of data and throughput that they needed for these intelligent signs and the video and things like that that they have along the roadways. And I believe this is the last one, but the Port of San Diego, again, they had a very complicated MPLS core network from a networking perspective. So if you're thinking about layer 2, layer 3 devices, they wanted a piece of equipment that could absolutely adhere to what their platform was, what their network infrastructure was on their side, and be totally transparent to the type of data packets that were flowing upstream and downstream. They've got their own way of doing things, and they didn't want to put a device in that was going to have to complicate their network structure in order to fit into to what they were trying to do. And they've got a complete data, voice, video network, a lot of VLANing, a lot of special things going on within the system, and they chose Redline based on the fact that, again, we were a layer 2 transparent bridge. We could handle the VLANs and different things that they were doing on the network, and not only handle them, but we were able to offer a quality of service based on their own tags, so that when they send something with a high priority, our radio could read that, give it a high priority as well, and send it across transparently to their core without them having to change the way their network internally functioned. So it was a tremendous thing. We've had a great deal of success in being able to get, again, the video, the voice, the data, all of those networks functional and operational in such a big area at some of these port sites. So it was a very key thing. So in conclusion, from a Redline perspective, again, our virtual fiber line, our point-to-point line, it's unmatched reliability and capacity. We've had a tremendous amount of people come back to us after the fact and say that, we've had a radio that we put in 4 years, 5 years, 6 years ago, and we forgot about it. It's one of the great things that you can put something in place and you don't have to babysit it anymore. The small footprint and the non-line of sight nature of our products, depending on what the spectrum is. It gives the transportation industry, but I guess everyone as a whole, a lot of different value-add propositions, if you will, to solve different problems. It's not, oh, you take this subscriber, and if you're going to be a service provider, you use it. If you're going to be this, you'll use it. You have the ability, depending on the packaging and what's available, to have different profiles, different things, all within different packages to solve the same problem. Spectrum choice. This industry, typically it's an unlicensed spectrum thing. Usually guys are not given spectrum to be able to use. So for you, they have the ability to go from 400 megahertz with the radio all the way up to your traditional 5 gig and anywhere in between. Gives people a lot of different options that they can use this radio for and adhere to what they need to do without having to pick a different product, a different name, a different whatever every time. It's the exact same radio. It's available in different frequencies, but your training, your GUI, the way it looks, the way you deploy it is always identical regardless of spectrum. So from a Redline perspective, we're seeing a tremendous uptake in, again, the mission-critical data. Look at the military, look at the energy sector, and of course the transportation industry follows that same key in the fact that, again, they're putting radios in, they 100% have to work, and they're choosing Redline in order to solve those issues. So I'll pause there and stop. Definitely appreciate everyone's time, and Lisa, I'll hand it back to you.
Okay, thanks, Eric. We did have one question. Will the presentation be available online? And yes, it will. I'll be sending out an email, follow up with a recording of the webinar, and with a copy of the PowerPoint. So if anybody has any questions they'd like to submit through the chat right now, we can take them. And if not, maybe you can address a couple of the ones that were asked, Eric, on the registration.
Yeah, absolutely. If you want to call them out, I can go through them.
Sure. There was a couple of people who were asking about electronic signs at transit stops and mobile devices to record information at transit stops.
Okay.
I guess how it's accomplished.
Sorry, go ahead. I interrupted you.
Sorry. I guess basically the question is how could they do that? How they could connect electronic signs at transit stops, or generally transit stops.
Yeah, so I mean, from a Redline perspective, as we can probably see from the case studies, and I don't know if that shed any more light into some of the things we do, but from a Redline technology perspective, we're connecting to digital signs, sensors, things that flash on and off different roadway signs, video, data access for first responders in different pockets of areas. Our RAS product in particular has been one that's been very, very significant, if you will, for people that need different operations at different times. So if you're driving to one area and you have to stop and do comms or collect video, we have a product that automatically acquires. And then as you go to a different area and you have a different mandate in a different place, this same product, providing it's lit up from a sector controller perspective, will again give you that same access without the guys in the vehicles really having to do anything. So it's been a product that's been extremely popular, and purpose-built, if you will, for that type of kind of more nomadic / mobile operation.
That's great.
One of the things I want to point out, excuse me, Lisa, on a recent project, Eric mentioned it earlier with the New Jersey Turnpike, there was a variety of different locations where we had to network back to a central tower, and each location had its own set of devices that needed to be networked back. Some only had, some had a smart sign, some had a smart sign and a video camera, some had a smart sign, a video camera, and a lane redirection sign. Each one had its own bandwidth requirement. The unique thing about the Redline radios is that you can actually set up on an individual case-by-case basis, on a subscriber-by-subscriber basis, a specific profile for that radio. So you only need to deliver the bandwidth required for that particular profile. And that's important when you're trying to get as much capacity out of a base station as possible, and you're not slowing your networks down because everybody has the same access or the same the same type of capacity. So again, very purpose-built radio product with the right type of form factors for the industrial types of markets that are being addressed here.
Absolutely.
Okay, there was one more question about maybe you did address it. Adverse effects during inclement weather and mitigating actions recommended.
Yep, so from a weather perspective, I mean, weather a lot of times has to do with frequency. So when you look at your traditional licensed microwave bands, typically 11 gigahertz and above are actually, they're affected by something called rain fade. In these spectrums where our industrial products are kind of built, which is 5 gigahertz and below, it can be raining, it can be snowing. There is no adverse effect whatsoever when it comes to weather conditions. These frequencies penetrate the air regardless if it's a snowstorm or regardless if it's a hailstorm. You know, we've seen some interesting things happen in, some of the Middle East places with sand, but when it comes to pure weather, there is no effect from a rain fade perspective with these radios. They propagate through that at a pace that has no effect from a physics perspective.
Okay, great, thanks. And the last question I have was Redline Virtual Fiber quotes. Would this work in a multi-level garage?
So we are doing some testing of mine sites and in-building stuff. Typically, with the applications that we're kind of coming from an industrial perspective, typically it's long-range, outdoor, big, massive areas. Usually people from a deployment perspective, when they go indoors, usually look at other technologies because they're more purpose-built for short-range, communication. So you'd have a lot of reflections, and you'd have it's almost something that we'd have to look at on a case-by-case basis. But typically it's more outdoor wireless, not really geared towards the indoor wireless space. Great.
Thank you. So I don't have any more questions that have been submitted. I just want to remind everybody again that I have recorded the webinar, and I will send out a link to that. And if you have any questions afterwards, don't hesitate to send them. I can redirect them to Eric or to Tom or to whoever. And we've got a slide up there just showing how to keep in touch with us. I always put all of our recordings up on our YouTube site, and you're on my list, so if there's anything that is of interest, I have quite a lot of webinars scheduled, and we talk about in-building. I'm actually doing a series on in-building DAS in May on the 7th, on the 14th, and the 28th. We have webinars on DAS, so you can visit our website to find out more. And I think that's it. Thanks a lot, Eric and Tom.
No, I appreciate it. And again, thanks everyone on the phone. I know it's Friday, but again, appreciate your time. And please let us know if there's any additional questions, follow-on questions. We'd be more than happy to sit down and discuss your questions.
Great. Okay,
thanks,
everyone have a great weekend.
Thank you.